welcome to Science Spectrum with Don. This is a continuation of the third part of the first lecture. So this is the fourth part of the first lectures. Alright, so to give the answers quickly from where we stopped, 15 times 5, 15 times 5, that's 75. And of course, we divide that by 4, divided by 4. The answer would be 18.75. That's Q's mark, P's mark. This is 45, 45 divided by 4. And of course, this is 11.25. That's the mark P obtained. And then for R, that's 7 times 15. That's 105 divided by 4. Okay, this is 26.25. And of course, there are lots of questions we could explore in this. So let me just do a few. And of course, we'll talk about comparing ratios and also talk about the types of ratios and of course their properties. All right, so I think this should be the last question I will treat on this. The next example is if we're given ratio A to B the same as C to D, the same as E to F. Prove that this ratio is that, prove that this ratio, okay, is equal, prove that this ratio is equal to, so it's equal to this. We have 4a squared plus 3c squared minus 7e squared over, all over 4b squared plus 3d squared minus 7f squared. And of course, this is all raised to power half for the square root of it. All right, straight to the point, you could see that each of these pairs of ratios are equal, so they have a constant. It's just a constant, the same value. So the solution to this, ratio A to B is a constant. The same goes to C to D is a constant. And of course, the other pair is also a constant. So the goal is, I want to express these terms A, C, and E in terms of KB, KD, and KF. So A becomes KD, C becomes K, A becomes KB, C becomes KD, E becomes KF. And of course, what will I do? I could stick in KB, KD, KF for A, C, and E. And of course, you could see that I would have like terms in both the numerator and the denominators. All right, so still on that, straight to the point, move on. We have, this is 4, A is KB squared plus 3C is KD, was carrying in power 2, minus 7E is KF and is carrying in power 2 over, let's stick this in the bracket, over 4B squared plus 3D squared minus 7F squared. And of course, all raised to power half, which is the square root of it. And of course, this will boil down to be, I have 4k squared b squared plus 3k squared d squared minus 7k squared f squared. Everything divided by 4b squared plus 3d squared minus 7f squared. All raised to power half, or just say the square root of it. So I could factor out the k squared now. So I could factor out the k squared. Then what I have left is 4b. I have 4b squared. This term divided by k squared, I'm left with 3d squared plus 3d squared. Then plus times what will give me minus is a minus. This term divided by k squared will delete out, and I'm left with 7f squared over 4b squared plus 3d squared minus 7f squared. And of course, I could take everything to power half. That's the square root of it. So the answer would be this term and this term, they are the same. So they delete out. So what I have left is root k squared. And of course, the power 2 will cancel the power half, law of indices. And of course, I'm left with a k. And of course, this is the answer. Now we move on to, you may beam this for a while. We move on to comparing of ratios. Comparing ratios. We could compare two or more ratios by sticking a greater than or less than sign. So let's comparison of ratios. All right. So if I have ratio A to B, of course, if I compare this, of course, ratio A could be greater or less than B. If A is greater than B, it means B is less than A, and of course, vice versa. All right. So I give an example. What if it is of this kind? I have a pair of ratio, another pair of ratio C to D. I could compare the two. I could say ratio A to B could be greater than ratio C to D, which implies ratio C to D is less than ratio A to B. So I could compare two ratios. So I give you working examples. We'll compare ratio 4 to 5 and ratio 18 to 25. So solution, straight to the point. Ratio 4 to 5 is the same as 4 over 5. And of course, in decimal, you get 0.80. And ratio 18 to 25, same as 18 over 25, which is same as 0.72. So you could see right to your own very eyes that 0.8 is more than 0.7. So it simply means that this pair of ratio is more than this. So the final answer would be that ratio 4 to 5 is greater than the ratio 18 to 25. But there is an alternative way. I'll deal with that pretty soon. So this is greater than 18 to 25. Alright, now the alternative way, what the alternative way is this. I have alternatively. The first pair of ratio is ratio 4 to 5. And of course the other pair of ratio is 18 to 25. And of course, if we cross multiply this, of course 4 times 25, that will give me 100. And 5 times 18, this is a 90. You could see that 100 is more than 90. And it simply means that this pair of ratio is more than this. And of course, I could give you more of things like this. So we could do ratio 2 to 5 and compare ratio 2 to 5 to ratio 3 to 4. It's a straightforward. Instead of dividing and getting out and getting the decimal form of it, we just say 2 to 5 and 3 to 4. So we'll multiply. 4 times 2 is 8. 5 times 3 is 15. And of course, this is more than this. So I will say, therefore, ratio 3 to 4 is more than or is greater than ratio 2 to 5. So we could compare two pairs of ratios. So I may need to wipe this off. Maybe we need to bring this with the camera for a while. And I'll go ahead and clean up. All right. Now, I'm done with worked examples in ratios. Now we'll talk about the properties of ratios. Just briefly. Now, the first thing, if I have ratio A to B, I could write that as ratio A to B or A over B in fraction. Now, if I multiply ratio A to B with a positive non-zero digit, let's say this is 6. Of course, it wouldn't alter anything here. So this pair is the same as this because I could delete out the m. This is the first property. And of course, so I could say this is just the same as this. They are the same. The second one is I could, given ratio A to B, I could divide each of these by a positive non-zero digit. And this is ratio A to M. Okay, A over M, ratio A over M to B over M. And of course, if you do the math, you see the m will cancel out, and I'm still left with this. So of course, these are the properties of ratios. Now, ratio has types. There are types of ratios. So we'll quickly run through that, and we'll wrap it up for ratios, and I'll move on to proportions. All right. So the types of ratios. Types of ratios. Types of ratios. This actually depends on if the antecedent is greater than it's either greater than or less than the consequent. So if you have this scale ratio, and of course the antecedent is larger than the consequent. So what this would imply is, we call this kind of ratio, we call this ratio of greater inequality. Of greater inequality. Inequality. This would imply, if I add a positive number to this pair of ratio, it simply means that the value I will get out of this must be less than this. So in other words, ratio a plus x, ratio a plus x to b plus x has to be less than ratio. Yeah, has to be less than ratio a to b, that's the original ratio. So we could give it a try. Let's say this is 5, this is 4, because a must be greater than, and of course let's say x, let's assume x is just the 1. So we could check that out. This is 5 plus 1. This is 4 plus 1. And of course let's see if it's less than this. So this is 6, and of course this is a half of 5. So this is 5 to 4. This is 5 to 4, A to B. And of course, we can just check that out. 6 to 5, 5 to 4. This is 6 times 4 is 24, 5 to 5 is 25. So this scale ratio is more than this, and of course, it validates this fact. Now, the second type of ratio is when the consequence is greater than the antecedent. So we call that ratio of lesser inequality. This is the first type, ratio of greater inequality. The second type is when we have a given ratio, and of course the consequent exceeds the antecedent. All right, now we call this ratio of lesser, the second type, of lesser inequality. Ratio of lesser inequality. So if I add up a positive number to each of these, a plus f, and I add another number, I add the same number to this. Of course, the answer I will get must be greater than the pure original ratio. So we will give it a try. Let's assume this is less than, so this is a 4 and this is a 5. And let's still say x is 1. So we are good to go. This is 4 plus 1, that is 5. And 5 plus that is a 6. And of course, let's see if this will be this, if this would either exceed or be less than this. Alright, so we could check that out. We could compare this. 5 to 6, 4 to 5. This is 25, this is 24. And right in your own very eyes, you could see that this pure ratio is more than this. And of course, it validates this fact. And of course, we could have equality of ratios, which is the third one. Again, we need to name this. Equality of ratio, the third one. If the consequent and the antecedent are of equal values, we call that equality of ratio. So number 3, we have when you have this pure ratio, and of course A is the same as B, we call this equality of ratios. Equality of ratios. So if you add a positive non-zero digits to each of these pair, you must get the same answer, because the ratio has to be 1, because they are all the same. Now, the fourth one, okay, so because of time, I may need to wrap it up here. Thank you for tuning in. You may need to like, share, and subscribe for more content. Thank you.